AP Calculus AB, Unit 6, Day 12, lesson. Now this handout, which if you have a hard copy of, has a handout for the 613 lesson, which I'm going to do in a separate video, separate day. So, but they're both together. So this is just a quick one with a little extra log and exponential derivatives, which we've already learned this unit, but just to get a little more practice with, show you guys some tricks to try. So if we were to just take the derivative here, it would be kind of tough. It would be y prime equals 1 over what's inside. And then you have to take derivative of what's inside, and that'd be quotient rule, right? Quotient rule. So it's going to be low d high minus high d low all over low squared. And we got to try and clean that up, I guess, you know. So this is going to be 2x minus 2x cubed plus 2x cubed over 1 minus x squared times the reciprocal of this, 1 minus x squared over x squared. So those cancel. These guys cancel each other out. And so now you have a 2x and an x squared. We could reduce one of the x's out of that. And final answer would be 2 over x, parentheses 1 minus x squared, or 2 over x minus x cubed. And it worked out kind of nice, but it was a little crazy. Just as an extra thing, you know, what if I asked you to do a line check, find where it's increasing or decreasing or things like that? Just sort of an extra problem, like increasing, decreasing, relative maxes and mins. You'd want to take this and set it equal to 0 and define, and you probably want to factor this. This is the difference of squares. And set it equal to 0 and define. So this is just a little extra. And you'd have 0, 1, -1 for your critical points. And you do a line check in order, left to right, test a point. X equals 2 is going to be negative, positive, negative, positive. So we're increasing, decreasing, increasing, decreasing. Relative min, relative max, relative min, relative max. So lots of good stuff. But what about the domain? I'm just throwing that out there. What about the domain? So you got to be careful. The inside of a natural log has to be greater than 0. That's one issue. Okay, so we'd have to figure that out. This would be 1 minus x, 1 plus x. Also, by the way, x equals 1, x equals -1 cannot be allowed because they create division by 0 in the original function. But they're not going to anyway. So you would do like a line check, -1, 0, 1, test a value, x equals 2, is false. True, true, false, open dot, open dot, open dot. So this is the domain, is -1 to 0 and 0 to 1. So any answers outside of that we can't use. So this is outside the domain, this is outside the domain, and 0 itself is outside the domain. So there is no relative min, by the way, because it's like a vertical asymptote there. There's no relative min. It is decreasing here and increasing here, but you would not include the endpoints here because they're not in the domain. Usually we include the endpoints. There is no relative min. There's no relative max. Anyways, just some interesting things to consider. Now, really what I want to do is show you a different way of taking the derivative in the first place. So I don't know if you guys remember this from recent lesson. You can use log rules to split it up first. So we could rewrite it as y equals log x squared minus log of 1 minus x squared. We could even bring the 2 out front. Y equals 2 log x minus natural log of 1 minus x squared. I think that's as far as we can go. But that gets rid of the quotient rule. It's rid of part of the chain rule. So y prime equals 2 over x minus 1 over 1 minus x squared times derivative of what's inside is negative 2x. And there you go. There's a derivative. I mean, you could write it. You just write it like this if you want, plus 2x over 1 minus x squared. There's the derivative. You could combine them into a single fraction with least common denominator. Multiply the top and bottom of this one by 1 minus x squared. It would be 2 minus 2x squared. Multiply the top and bottom of this one by x. You get 2x squared. All over x, 1 minus x squared. And hey, eventually we get something that looks exactly like the answer we got over here. Not that you would have to do that. Anyways, just some options to consider. Okay. This problem right here, we could take the derivative implicitly. So that would just be because y isn't on its own. So we could, let's see, derivative e to the xy is e to the xy times derivative of what's inside would be a product rule. X times derivative of y dy dx plus y times derivative of x is 1. The derivative of minus 2 is 0. Derivative of 0 is 0. And then we got to get dy dx by itself. That's the thing we want. So, I mean, we could distribute this. X e to the xy dy dx plus y e to the xy. We could move this term to the other side. We divide both sides by x e to the xy. And we finally get dy dx equals negative y over x. So we can do that. I mean, that's probably what I try. I mean, we could try it explicitly. I don't know if that's a better option, but you would want to solve the equation e to the xy minus 2 equals 0. You want to get y by itself. So you would move the 2 to the other side. I isolate the exponential part, take the natural log of both sides, because you can't just distribute natural logs to these terms separately. Move this out front. And so you just get xy because natural log e is 1. And then y equals natural log of 2 over x. Or natural log of 2 times x to the negative 1. Might be easier so you don't do quotient rule. So now we could try the derivative. Dy dx equals negative natural log of 2, x to the negative 2, negative natural log of 2 over x squared. So this is my answer for the derivative. The interesting thing is these should be equivalent to each other. I mean, they look different, but they're the same. If you were to take this right here and plug it in for y, they would look exactly the same, right? So look different, but they're equivalent. The thing you have to watch out for is on multiple choice on the AP test, because you're at the mercy of their answers. So what you should do a lot of times before you even start working on the problem is look at the answers and see what kind of form they are. And then from there, decide which approach would be more efficient for what you're trying to get. Anyways, also just a reminder of the derivative rules. E to the x is e to the x, but sometimes we encounter exponentials that don't have base e. So they are b the x, but then there's an extra natural log of the base. So just a quick reminder of those derivative rules. The assignment is worksheet 612. Some more multiple choice practice. So try that out. And we're getting close to finishing this unit.